Hi, welcome to Unit 49. In this unit, we're going to focus mainly on comets. So basically, we're going to describe the structure of a comet and how some of them are actually visited by some of our probes, and then explain the time sequence of how the comet forms and goes back to its original form, and describe the origin of the comets, where they come from. Basically, there are two strong candidates, the Kuiper belt and the Oort cloud, and describe meteor showers and how they are named. So this is a comet, okay? If it's visible like this one, I mean, this is a rare event, but most of the times they are not too visible because the position of the Earth and where they are actually in this form may not be too close. So, and you can clearly see the main feature is there are two main features actually. You can see the head, the leading part of the comet, and this long tail. As a matter of fact, if you look up close, you see there are two tails in here, one that is on this side and one to the other side. We're going to talk a little bit on detail about that. So the comet basically has a coma, and inside the coma there is a nucleus. That's the head. Okay, so the head is made up of two parts. The nucleus. That's really where the part where the solid part of the comet is, and then the coma, which is the evaporated materials that are basically floating next to it, and then there are this tail in here. Okay, uh, so the coma is about 10 kilometers, but the tail itself can extend to hundreds of thousands of kilometers. That's what you see in the sky in there. Okay, that's the main feature actually of the coma of the comet. Okay, so these are some pictures of some of the comets that have been observed. We have Halley's Comet in here that was visited by Giotto in 86. It's about, in 1986, that is. That's about 15 kilometers across, okay? So that's really the bulk of the comet. And you can clearly see here the materials that are evaporating, sublimating, I should say, from the surface, because sublimation is not like necessarily like evaporation, because sublimation takes material from a solid state immediately to the gas state without going through the liquid form state. Okay. And then we have Wild 2 here that was visited in 2004 by Stardust. That's 5 kilometers across. We have Temple 1, which was visited by Deep Impact in 2005. And again, that's about 5 or 4 kilometers across. And then we have here this Churyumov Gerasimenko. I'm sorry if I messed up this name, terrible, big time. But it was visited by the Rosetta in 2014. So again, that's about 4 kilometers. So the shapes are irregular shapes, and there was a unit when we discussed basically the sizes of the solar system objects. If they exceed the 400 kilometers, they become circular or spherical. When they're too small like this ones, they don't have to. These are like potato shapes objects. Anyway, so we have seen them up close basically with some of the missions to them. Uh, Comets, they go through stages. Basically, when they come up close from the sun, they heat up, and the process of sublimation, as I mentioned, basically happens. And because of the sun radiation that hits them, they glow. They become visible. Okay, and actually, that's when they develop a tail also because of the solar radiation. Solar radiation is hitting them. It's called solar pressure, and it basically pushes the materials away in the opposite direction from the sun. So again, this is the main structure. The sun is this way. There are two kinds of tails. There is the ions basically in the materials that have sublimated, and there is the neutral dust basically that does not have a charge. So dust that does not have charge is just basically driven by the forces of gravity, basically inertia being left behind. Okay, and so this is the path of the comet most likely, and this is the path, the sun, the position of the sun where the sun is. So at this point, not necessarily just by inertia. I'm sorry, I said a mistake. The biggest actually contributor in this case is solar radiation. It's the one that is pushing the materials. But because these are ionized, these have charges in them, and the radiation from the sun also has some charges in it. It's a combination of both electromagnetic and also ionic. So in this case, it's going to interact with the charges and give them a different path, okay? And that's immediately opposite to where the sun position is, okay? Whereas this one is a combination of the solar wind and solar radiation. In addition to that, you have the inertia and the way that the comet is moving in the sky. At about 5 astronomical units or beyond, the comet is basically a solid structure. It's too cold to see any materials evaporate from it. And then around 3 astronomical units, at that point, the sublimation process starts and there is a coma that starts to form around it, okay? Up close, then the solar radiation becomes more intense because you're closer from the sun. Solar radiation is high. So in this case, the two tails starts to form. One that is ionic and the other one that is dusty. And in this case, it's pointing away. The comet is moving this way. It's moving in the opposite direction. And it's opposite from the comet. So it's leaving it behind, basically. And again, it's always pointing away from the sun, to be honest with you. And there is that kind of a curve in here that forms for the dust tail. But the ions usually are straight up. The ionic tail is pointing down, again in this case. And in here, there is the effects of gravity or the effects of, inertia. In addition, the main player in this case is actually solar radiation. The inertia in this case, it's acting more and more because of the fact that we're far away from the sun and the solar radiation for the dust tail, but for the ion tail, it's always pointing opposite to the sun. But the key thing in here is that this is pointing in leaving the comet. As the comet is leaving from the sun is basically pushing all of its tail in the opposite direction. So the tail is actually leading the actual coma and the head. So the head is actually behind, okay? So it's the tail that is leaning, and then it starts to coalesce and come together. And as it does at the end, it goes back around 4, 5 to 6 astronomical units. It goes back to its original form. The structure, it goes on a very long path and repeats. The composition of the comet, because of the fact of the solar radiation, we have a chance actually to do spectroscopy and analyze its structure. It's mainly made out of water because its density is very low. It's less than 1 kilogram per liter. It's actually more of a dirty snowball than actually anything else, an icy object, okay? It's made out of water, H2O, carbon dioxide, monoxide, the methane, ammonia, and somewhat traces of other elements in it, okay? So that's basically the composition of the comet. As I said before, it originates mainly from the Oort cloud. Those they take a very, very long time to reach the Earth, that extend around 100,000 astronomical units. So those are some of the objects. Some of them probably this is the first time they go around the sun, okay? In addition to that, you have the Kuiper belt in here. Kuiper belt, the difference between the two Kuiper belts is part mainly of the same ecliptic plane, whereas the Oort cloud is too far for the influence of the gravity from the sun to influence. It's more like a spherical distribution than that. And sometimes we have comets that come from outside of the solar system, like Oumuamua, and also recently, last fall, where we had the 3I Atlas, okay? And that behaved, because that seems to have formed even before the solar system has formed. It never really went through the stage. The first time it got very close from a star was near the sun. So it developed something called an anti-tail, basically tail pointing toward the sun. So because the first time that it injects some of the materials from within, okay? So that's why the weird kind of a headlines, they were all over the place. And sometimes people were thinking that it's some sort of an alien shape or something. But it's really a comet from outside of the solar system, exo comet, if you want to call it as such, okay? Now, the meteor showers, because a comet basically has this long tail, at times it passes through the path of the Earth, through the orbit of the Earth. So once the Earth passes through those, that dust that was left from the cloud, from the comet, the Earth goes through it, so it enters the atmosphere of the Earth and it burns through the atmosphere, and that's what we see as meteors. It looks like it's meteor shower because there are too many of them. Okay. The region where they emanate from it is called the radiant, And that's actually depending on the time of the year. There is actually usually kind of a specific constellation, and depending on the constellation, that's the names that they give them. So the Leonids are coming from the Leo, Perseus, Perseids, and so on and so forth. So here are more of the meteor showers. January, for example, and the rate of which they come in, and so on and so forth. Okay. The Perseids, which is in around August 12th, they come around 40 to 100 per hour. So again, they're all related to comets. Thank you.